The outline of the presentation, as you can see here, light-matter interaction, we're going to start with the basics, how light interact with matters, and how this whole dynamic and static and electrophoretic measurements are made. And we're going to go from the basics all the way down to working examples and what goes wrong and what are the interactions and what are the pitfalls. I'm going to cover the first section, like Kevin said, dynamic light scattering, hydrodynamic size, polar dispersity. We're going to take a quick break, and then intensity weighting and distribution transform, which is very important also. After that, it's going to be Ulf's part to continue on this. Light, matter interaction, scattering intensity. What we have here is light interaction with matters. How does light interact with matters? Well, it can be either transmission, no interaction, it passes through. It can be reflection. It's a bit of a simple explanation here. It could be absorption, which can be re-emitted with heat, or fluorescence, which is re-emitted with light at longer wavelength, or scattering. Scattering, when there's scattering, light passes close to a molecule, induce a dipole moment, and this light is scattered, and we're going to see how it's scattered at all the angles. And here in this case, we have in green in the center a small particle, and around it we have the light coming in at the front here, and all around, light is scattered in all directions. The intensity of the light scattered will depend on many factors. First, how big this particle or protein in the center is, and then it will depend on the angle at which we look at, the refractive index of the solution, the refractive index increment called dN over dC, wavelength of the laser. So there's many parameters. Toward the end, I'm going to show you a bit of the equation. It's going to be fairly complicated, but the model is simple. You have a laser plane, a laser wave coming in, hitting a protein, and they're scattering it all around, and then we detect the scattering intensity. We're going to define here a scattering volume. This is what you have there. A laser will emit a beam, and the cross-section between the beam and the detector optics, this part here, is defined as the scattering volume. Obviously, the more proteins you have in the scattering volume, the more scattering intensity. Now, scattering volume can be small, big. We're going to see later on that they don't always intersect at 90 degrees. We're going to see all this, but when we define a scattering volume, this is the intersection between the laser and the optics. Now, what does the optics see? It sees something that looks like that. This is pretty awful. It's moving up and down all the time because the proteins in solution are going through Brownian motion. So they're moving. It's not a static thing. The proteins are moving, so the intensity fluctuates around a mean, the blue line here in the center. The mean is called the static intensity. We're going to see what it can be used for static light scattering measurements. And the fluctuation here can be used also. And this is for dynamic light scattering measurements. And this is what the electronic will use, what the system will use to get the size of the protein or the particles in solution.